We're solving problem 25 from the 2022 F equals MA exam B. Two masses are initially at rest, separated by a distance r, and attract each other gravitationally. If their masses are m and 2m, they will collide after a time t. How long would they take to collide if they both had mass 2m? So we have this rough equation where d is the distance between them. And what we can do is we can set equations equal to each other by energy, where E is equal, gravitational energy at this point is negative G times mass 1 mass 2 over R, which is equal to negative G mass 1 mass 2 over D, which is equal to the sum of the energies, which is 1/2 mass 1 V1 squared plus 1/2 mass 2 V2 squared. Since we know that there are no other external factors affecting this gravitational attraction, we can say that M1 V1 is equal to M2 V2. So we can then rewrite this by adding this over and changing this last equation. So this becomes G mass 1 mass 2 times, well, this is just going to be 1 over D minus 1 over R, because you add over it and then you subtract the R, which is the negative. And then, well, right away here you can see that you can factor out a 1/2. So this is 1/2 M1 V1 squared plus M2 V2 squared. Now we want to get the same variables in this equation, so we can substitute a value for V2, where from this equation we divide both sides by M2 to get that V2 is equal to M1 V1 over M2. So this V2 becomes M1 V1 over M2 squared. Since it's being multiplied by an M2, this cancels out 1. So all in all, this part of the equation would just be M1 squared plus V1 squared over M2, or times. At this point, you can see that in this equation you can factor out V1 squared. So this one becomes 1/2 V1 squared. This is M1 plus M1 squared over M2. But since we want to have the same variables, we have to incorporate a factor of M2 in here. So that's where we can change this factor into M2 times M1 over M2. Because M2 over M2 is 1, this value stays the same. And we do that so that we can sum the denominators, and it makes us a lot easier for us to solve. Now, what we see here is that this is pretty hard to compute, but we have this equation here. So in this case, we can divide both sides by a factor of M1. So when we do that, our new equation is going to be G times M2 1 over D minus 1 over R is equal to, well, this is denominator is 2M2, we know that, because you just factor out the parentheses. And then when you divide by M1, this cancels out, and this just is M1. So this is M1 plus M2 times V1 squared. So now we have this equation. We can isolate the first velocity, the velocity of the first object, where we get that this is V is equal to, well, this is M2 because you take the square root later on, but then you multiply the M2 twice because there's 2, and then since it's a square, it gets factored out of the square root. This is 2g, and then you divide by the denominator here, m1 plus m2 times 1 over d minus 1 over r. This is what you should get, and this is v1. You can do the same exact process for the second velocity v2, where v2 is equal to m1 times the square root of 2g over m1 plus m2 times 1 over d minus 1 over r. Now, we have this, and what we really want is, well, the relative velocity is simply the sum of these two velocities, v1 and v2. So the sum would be the square root of 2g times m1 plus m2 times 1 over d minus 1 over r. And this whole relative velocity, I'll just write v sub r, is proportional to the square root of m1 plus m2. Now in this instance, we know that time, or we can estimate that time is about the reciprocal of the relative velocity. So therefore, we can say that time is proportional to m1 plus m2, and then this is this is to the power of -1/2. We then get that t prime over t, or the change in time, is equal to the square root of m plus 2m, because the other mass is 2m, and then this is just 2m plus 2m. Take the square root of that, is equal to square root of 3/4. So we know that the factor is 3/4. So for our answer, for this problem, it's d, or the square root of 3/4 times t. So if we just add on a t at the back, this would be our answer for problem 25.